This is the first video for section 17-3 in accelerated geometry. Today we're going to be learning about the unit circle. And before we ever even get started, I want to make sure not only do you have the printout of your notes for today's video, but have you also printed out a blank unit circle to fill in as we work through today's video. You should have that file also on your e-class for you to print out. And even if you don't have that, on the back side of the second semester formula sheet, there is a blank unit circle that you can use as well. So either one of those you're going to want to have out so that you can fill it in as we go. If you don't have one of those, I want you to pause this video right now and go print one or the other of those out. Don't try to draw it by hand. Okay, so now that we all have a unit circle to work with, we'll get to actually using it in a little while. The essential question for this section is, what is radian measure and how is it used? So our vocabulary is radian and unit circle. And we're actually not going to be talking about radians at all today. We'll talk about it in the video for tomorrow, but not in this particular one. But we will be talking about the unit circle. The unit circle is a circle that has a radius of 1. And it doesn't say it in the definition, but it is also centered at the origin. So for example, this blue circle right here is a unit circle. It has a radius of 1 and it is centered at the origin. So any point on that unit circle, point P right here, can be represented with the coordinates x, comma, y. And then if we draw in the x and the y coordinates and draw in the length or the distance to point P, that forms a right triangle right here. This is kind of like what we were doing in section 17-2. So the bottom length here of the right triangle is x, the vertical length is y, and then the hypotenuse in this case is always going to be a length of 1 because we are on the unit circle. So the radius is 1, meaning that anywhere around this circle, the hypotenuse for point P would be a length of 1. And then the angle in here from the x-axis up to that hypotenuse is theta. So in terms of this orange triangle then, the sine of theta would be opposite over hypotenuse. So looking at this triangle, that would be y over 1, or simply y. Cosine, being that it is adjacent over hypotenuse, would be x over 1, or simply x. So really, all I need to know are the x and the y coordinates for point P, as long as point P is on the unit circle. And if it's on unit circle, then the coordinates for the point could either be represented as x comma y, or going back and looking at the trig ratios, x is the same as saying cosine theta, and y is the same as saying sine theta. So this is a new way to represent the coordinates for any point on that unit circle. But once again, it has to be a circle of radius 1. This does not apply to the point problems we were doing in 17-2 because we did not have a hypotenuse of length 1. So if that's how we could find sine and cosine, why can't we use those same relationships on the unit circle to find the other 4 trig ratios, starting with tangent? Tangent, if you remember from any of these pictures, or even from what we did last week, tangent would be opposite over hypotenuse. So it would be y over x, or we could even say sine of theta over cosine of theta, since y is sine and x is cosine. Cosecant, if you remember, is the reciprocal of sine. So rather than being equal to y, it would be equal to 1 over y. And then secant, since secant is the reciprocal of cosine, rather than being equal to x, it would be equal to 1 over x. And then cotangent, since it's 1 over tangent, it would be equal to, instead of sine over cosine, it would be cosine over sine, or the x coordinate over the y coordinate for that point. So you're probably thinking, well, okay, what exactly am I supposed to do with that? Well, let's elaborate a little bit more on this unit circle. When we are focusing on the unit circle, we tend to only focus on 2 types of special right triangles, 30, 60, 90, and 45, 45, 90 right triangles. So for example, in this 30, 60, 90 triangle here, if the hypotenuse was a length of 1, and let's say that my theta down here was 30 degrees, let's see if we remember our 30, 60, 90 relationships. Remember the hypotenuse is twice the length of the short leg. So if the hypotenuse is 1, the short leg would be 1/2. And then the long leg is the short leg times the square root of 3. So it would be square root of 3 over 2. So over here on my unit circle, if I rotate up to an angle measure of 30 degrees, this point would have the x and y coordinates of square root of 3 over 2, comma 1/2 x, y, if I was to actually draw in a 30, 60, 90 triangle there. That also means that the cosine of 30 degrees is square root of 3 over 2, and the sine of 30 degrees is 1/2. We can also use this for a 60-degree reference angle. If we think about it that way, here's my 60-degree reference angle. Those basically just reverse. From 60 degrees, the opposite side, or the y-coordinate, or excuse me, the x-coordinate would be square root of 3 over 2. Not. The y-coordinate would be square root over 2, and the x-coordinate would be 1/2. Then we get to a 45, 45, 90. In a 45, 45, 90, if the hypotenuse has a length of 1, if you remember, the legs are both congruent, and the hypotenuse is equal to a leg times the square root of 2, which means that a leg would be equal to the hypotenuse divided by the square root of 2. And if we rationalize that, that becomes square root of 2 over 2, which also means that this side is square root of 2 over 2. So going to the unit circle, that means that at 45 degrees, I have an x-coordinate of square root of 2 over 2 and a y-coordinate of square root of 2 over 2. Okay, so here's what we're going to do. We're going to go all the way through this unit circle at all of these blue marks, starting at 30 degrees all the way around to 360 degrees. And we're going to label what the coordinates would be for those points. And we can do that really easily because all of these blue lines that are not on the x-axis or on the y-axis have reference angles of 30, 45, or 60 degrees. The only thing that could possibly change is the sign on the coordinates, depending on whether if you're in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant. So let's talk about 90 degrees first. 90 degrees is at this point up here, which if we're on a circle of radius 1, this point is 0, 1. So I know by looking at the coordinates for this point that the cosine of 90 is 0, and the sine of 90 degrees is positive 1. So then we go to 120 degrees. 120 degrees has a reference angle. Look what it's a mirror image to. It has a mirror image of 60 degrees. So it's going to have the exact same coordinate pair as 60 does, 1/2, comma, square root of 3 over 2. The only thing that changes is that if we're over here in this quadrant on any graph, I would have a negative x-coordinate and a positive y-coordinate. So that is a negative 1/2 right there. Then for 135 degrees, that angle has a reference angle that matches up over here with 45 degrees. So it would be negative square root of 2 over 2, positive square root of 2 over 2. Because I'm still in the second quadrant, so I have to use that negative x-coordinate. So I now know quickly that the cosine of 135 degrees is negative square root of 2, and the sine is negative square root of 2 over 2, and the sine is positive square root of 2 over 2. So then I go to 150 degrees. It matches up with 30 degrees, so it has the same coordinate pair, except the x-coordinate is negative. Okay, so I want you to pause the video now, and I want you to go through and fill out the entire bottom half of the unit circle, from 180 degrees all the way around to 360 degrees. Okay, so I want you to pause the video again and double check that all of your measurements from 180 degrees around to 360 degrees, that your coordinates match my coordinates. We should have -1, 0, negative square root of 3 over 2, comma, negative 1/2, negative square root of 2 over 2, comma, negative square root of 2 over 2, negative 1/2, comma, negative 3 square root of 3 over 2, 0, negative 1, 1/2, comma, negative square root of 3 over 2, square root of 2 over 2, comma, negative square root of 2 over 2, square root of 3 over 2, comma, negative 1/2, and then 1, 0. So there's your unit circle there. That is going to be extremely helpful. That is a very important thing. You either need to have those coordinates memorized or be able to logically think them through using a 30, 60, 90 or a 45, 45, 90 triangle every time. Because when you get to pre-calculus next year, and then when you get to AP calculus the year after that, you are expected to just know these things. The teacher could just immediately point at you and say, what's the sine of 135 degrees? And you would have to be able to say to me, square root of 2 over 2, without even thinking about it. You need to know these things. And so I thought another thing that might be helpful is if we go through and we fill out this chart now with not only the sine and the cosine, but the tangent, the cosecant, the secant, and the cotangent for 30, 45, and 60 degrees, just so that you have it all there in one big reference table. So if I go to 30 degrees, I have square root of 3 over 2, comma, 1/2. Remember that these coordinates go cosine, comma, sine, not the other way around. The easiest way for me to remember which comes first is that usually our coordinates are x, comma, y, but now they're cosine, comma, sine. Either way, it's alphabetical order. X comes before y in the alphabet, cosine, or C comes before S for sine in the alphabet. So it's in alphabetical order, the way you do it. So at 30 degrees, the second coordinate, the y coordinate, is 1/2. So the cosine of 30 degrees, or excuse me, the sine of 30 degrees is 1/2. The cosine is the x coordinate, so it is square root of 3 over 2. Tangent then is y over x. So it would be 1/2 over the square root of 3 over 2, which you can off to the side of your paper rationalize that. I'll show you down here. It would be 1/2 over the square root of 3 over 2. So this becomes 1/2 times 2 over the square root of 3, which is 1 over the square root of 3, which we then rationalize into square root of 3 over 3. So the tangent of 30 degrees is square root of 3 over 3. Cosecant would be the reciprocal of sine, so it would be 2. Secant would be the reciprocal of cosine, so you would need to rationalize that. So instead of 2 over the square root of 3, it would become 2 square root of 3 over 3. And then cotangent is the reciprocal of tangent, so instead of 1 over the square root of 3, it would just be the square root of 3. All right, so I want you to pause the video again, and I want you to fill out the table for 45 degrees and for 60 degrees. All right, so give it a look there. 45 degrees going all the way across, you should have square root of 2 over 2, square root of 2 over 2, 1, square root of 2, square root of 2, and 1. And then 60 degrees, you should have square root of 3 over 2, 1/2, square root of 3, 2 square root of 3 over 3, 2, and square root of 3 over 3. So that's just another quick helpful reference for you. Now, a little trick that I always teach my students for how to remember what is positive in what quadrant is a mnemonic device that we say all suckers take calculus. And as we say that, we write the letters down to those words going around starting from quadrant 1 to 2 to 3 to 4. All suckers take calculus. That tells you what trig function is positive in which quadrant. So A stands for all. Everything's positive over here because we have a positive x and a positive y in that coordinate. In the second quadrant, S, suckers, stands for sine. Sine is positive here, but not cosine, because we have negative, positive. So sine is positive over here, and then of course its reciprocal, cosecant, would be as well. but we're just sticking to the three main trig ratios here. So sine is positive, but everything else is negative. In the third quadrant, take stands for tangent. So tangent is the only of the three main. It's the only one that's positive because we would have a negative cosine and a negative sine. Negative over negative gives us a positive tangent. And then C for calculus means cosine because we have positive x, negative y. So see, cosine is positive, sine is negative, and then because we'd have a negative over a positive, we would get a negative tangent value. So that's just an easy way to remember, okay, I have a 30-degree reference angle, but I'm in the third quadrant, so would sine or cosine or tangent, what would be positive there? And that's especially helpful because really what we do with our unit circle, once we've created it, is we find trig ratios using 30, 45, 60, or even 90-degree reference angles very quickly on the unit circle. So we're going to do some of these together, and then you can do some of them on your own. Let's start with the sine of 270 degrees. So I'm going to flip back to my unit circle. The first thing I would do is look at my unit circle and find 270 degrees. Well, here it is. It's at 0, -1. And they asked me to find the sine of it. So then I would just look at my coordinates and say, okay, cosine, sine. So I now immediately know that the sine of 270 degrees is -1. I didn't have to draw any triangles. I didn't have to think about it. I just wrote it down based on the coordinates. Now let's do cosine of 120 degrees. So I'm going to go to my unit circle, go to 120 degrees. Here's the coordinates up here. Cosine, comma, sine. And they asked me for the cosine, so that would be -1/2. If you have your unit circle, these are very easy problems. Next, we have the tangent of -30. So on my unit circle, if I'm going -30, that means I'm starting here at 0 and I'm going down 30 degrees. So that's really positive 330. But that doesn't matter. We're just looking at the reference angle. And so I'm doing cosine, comma, sine. But I want tangent. So you could either do y over x, -1/2 over square root of 3 over 2, or you can go look at your table and see that tangent of 30 is square root of 3 over 3. However, -30 is in the fourth quadrant, and tangent in the fourth quadrant is negative. So rather than square root of 3 over 3, it would be negative square root of 3 over 3. Then we have cosecant of 210 degrees. So for 210 degrees, we would go back to our unit circle, find 210. Here it is in the third quadrant, and it has a reference angle of 30 degrees. So I would go look at 30 degrees. I want cosecant, which would be +2. However, 210 is in the third quadrant where sine and cosine are negative. So that would be -2. Secant of -135 degrees. So without looking at my unit circle, -135 degrees is going to fall down here in the third quadrant. Going back to my unit circle, it has a reference angle of 45 degrees. So I would go look up the secant of 45 degrees. So that would be square root of 2. But since I'm in the third quadrant, all suckers take. That is not secant or cosine. So it's going to be negative square root of 2. And then lastly, cotangent of 270 degrees. So cotangent is cosine over sine, or x over y. So let's go look on the unit circle at 270 degrees. Here's 270. The coordinates are 0, -1, x, y. So that would be, in this case, 0 over -1, or 0. You're going to get a ton more practice with using your unit circle to find these trig values really quickly. So come to class tomorrow with your filled-in unit circle and your filled-in table there, ready to go.